Good evening. My name is Fernando Pavia, and today I'm gonna talk about the Birch clustering algorithm. So, what's the Birch clustering algorithm? So, first, we're gonna have to learn what Birch stands for, and it stands for Balanced Iterative Reducing and Clustering Using Hierarchies. So, it is a clustering algorithm designed to handle large datasets efficiently by building a hierarchical tree structure called a CF tree. So yes, it is within the hierarchical clustering algorithms set. However, it is not a traditional one. Here, as you can see in the image, is a little representation of the process it follows, which I'll um, profound more on the next slides. But in general terms, it creates first it loads the data into a memory by building a CF3. Then it condenses the data, creating global clusters, and then it refines clusters until we have like not little clusters, but better clusters. Okay, so what's the CF3 or the clustering feature tree? Um, it's the heart of the Birch algorithm, and it is a compact tree structure that stores summary information about clusters. So this is why the Birch clustering algorithm works very efficiently with large data sets. And each node, called a clustering feature, stores the number of data points in the cluster, the linear sum of them, and the squared sum of the points. This allows it to summarize the data set without storing all individual points. And again, this is why it is very efficient with large data sets. Now we're gonna talk about the parameters. So first we have the threshold, which controls the maximum diameter of clusters. And basically, if a new point fits within the threshold of an existing cluster, then the cluster absorbs the point, and if not, then a new cluster is created within the point, using the point. And so the smaller threshold, the more and the smaller the clusters will be. And then we have the branching factor, which is an other parameter, and it has the maximum number of child nodes each node in the tree can have. It keeps the CF tree balanced, and by default it has 50, so 50%, balanced. Then we're gonna talk about the two main phases of the Birch clustering algorithm, which I already showed you the Leo diagram in the first slide. So the phase one is the building of the CF tree, which is very important. I think is the most important one. So the algorithm makes a single pass through the data, and it inserts each data point into the tree, compressing and summarizing clusters dynamically. And the phase two, which is optional, and it's the global clustering. So once the tree is built, Birch can apply another clustering algorithm like k-means or another clustering algorithm on the leaf nodes. So this way it improves like the clusters inside the tree. So you're applying like another clustering algorithm to the clustering algorithm. And so now I'm gonna present you the the code. It's just a simple code over here, the one we used in our project. So here it is. Let me scroll up so that you can see the data set. Okay, this is the libraries, the function, the plot function, and this is the data set. It's about um, health health themes, specifically variables that determine if a patient has probability of having a heart attack. So we first did a little bit of like a one hot encoder thing, but just manually with two variables that had strings values. Then we dropped the nans as usual. Then we made the labels on the point so that we can use this function. And okay, we apply k-means, etc. Okay, now we're here. So it works just as another algorithm. In this case, as you can see, we can also apply the optimization clusters, or, in other words, we can find an optimal number of clusters for the Birch algorithm. And it actually was the one that worked the better. As we can see here, uh, the methods for finding the optimal number of clusters had the same answer, which is 5. And so we applied here the Birch clustering algorithm with 5 clusters. And it actually went pretty decent. We didn't use PCA methods for cleaning the data set nor anything. We didn't reduce the dimensions of it because we wanted to see how the algorithms reacted with, we can say, a raw data set. Um, so it actually worked pretty well, and also we chose the label H, which, as you can see, is not so important in this case. Like, that is why the PCA is recommended to you to do before, um, or while cleaning the data. However, you know, comparing it with the other clustering algorithms like the agglomerative or the k-means, it worked pretty well, pretty decent. And well, now you have, and another clustering algorithm that works very well with large data sets, and it's easy to handle. There's no a lot of parameters. And well, thank you very much for this little class. Hope you find it for valuable, and well, see you in the next one. Thank you.